I'm Anil Kumar sharing with you excellent question on inverse trigonometric functions. The question is find exact value of sine within brackets cos inverse of 1 plus sine inverse of square root 3 over 2. So we could write cos inverse of 1 as, let us say, a. In that case 1 is equals to cos a. If 1 is cos A, what is sin A? Well, sin A should be, let's write down the formula, which relates these two things. We know cos square A plus sin square A is equal to 1. And therefore, sin square A equals to 1 minus cos square A, or sin A equals to square root of 1 minus cos square A, right? Normally we write plus and minus. How do we decide plus and minus? We decide based on the position, right? Okay, so in the quadrant system, we have to see in which quadrant you are. If you are in quadrant 1, all are positive. Here sine is positive, tan and cosine, so that decides the value. Well, in our case, cos A is 1, so we are going to get 0, right? So we are going to get 1 minus 1 square root, and therefore sine A is 0. So that is so simple. We don't even have to worry about the sine. Now, let's look into the sine inverse function, which is right here, sine inverse of square root 3 over 2. And let's say this is equal to b. In that case, square root 3 over 2 is equal to sine b. Now what should be the value of b? I hope you remember that whenever we talk about inverse trigonometric functions, we have to remember what values could be for a and b, right? So whenever we're talking about a cosine function, the value of a should be between what? 0 to pi. The cosine function, you could only find inverse. Inverse reverse is a function only if a is between 0 to pi. For b, b should be between minus pi by 2 to pi by 2, correct? Right. So the only value which satisfies this condition is what? Let's make a special triangle. So I'm going to use very basic concepts, right? That helps to understand better. Let me take some more extra time, but it helps. So in this special triangle, sides are 1, 2, square root 3. This angle is pi by 3, correct? We are looking for sine value of square root 3 over 2. Opposite sides, so we know what b is. So that gives you b as equal to pi by 3, right? Anyway, that's your triangle. When we know sine b is square root 3 over 2, from the triangle also, you can find what cos b is equal to. Cos b is 1 over 2, adjacent over hypotenuse. Correct. The idea of all this is to tell you that there are two ways. So I've shown you two methods. To find the other trigonometric ratio. You could use this concept, or you could just make a triangle and then figure it out. Triangle and this combination is better since you're sure about the sign. Perfect. In this case, both are positive. So we say, since both are positive, both values should be in quadrant 1, correct? And that's why we got them both positive. Right. Now let's begin to solve the question itself. We have to find exact value of sine of cos inverse 1 plus sine inverse square root 3 over 2, correct? So I'm saying cos inverse 1 is a, so I could write this as sine of a plus sine inverse is b. What is sine a plus b? Sine a plus b is sine a cos b plus cos A sine B, correct? We know all the values, so let's substitute them, okay, and find the exact value. Sine A cos B. So sine A cos B, sine A we just found as 0 and cos B we found as half, right? So these are the two values. So I'm substituting these. 0 times half plus cos A sine B is actually given to us, right? Is given to us, which is 1 and square root 3 over 2. So we'll write that value. Cos A is 1 times square root 3 over 2. Now this is 0, so we get the value as square root 3 over 2. So that is the answer. So the answer is square root 3 over 2. So I hope with these steps you understand now how to find such compound angle with inverse trigonometric functions. So we have 3-4 examples in this series where we have taken this combination in different quadrants, correct? So it could be in these quadrants with positive and negative value. That will provide you with the variety. So I'll encourage you to see other videos. Search by Anil Kumar inverse trigonometric functions. Feel free to post your comments and views. Thanks for watching. All the best.